Welcome back to Gate Baba. In this session, I'm going to solve all the previous problems on fluid kinematics. The first problem is the velocity potential function for a source varies with the distance r as it is logarithmic variation. I explained this concept in the class itself. Okay, no need to explain again. And the second question is the Newtonian fluid has the following velocity field, and he's asking the shear deformation. This question also have explained in the class. So answer A is correct. And come down the next question. Shown below are three pipe sections through which water flows as shown. Option A to D below pertain to the direction of net force on the pipe section due to the flow of water. Okay, he is asking the direction of the net force due to this flow of water. Okay, state which of the options indicate the correct directions of the force for pipe 1, pipe 2 and pipe 3. Okay, if you take the pipe 1, what is the force? In this direction some force is acting, and in upward direction also some force is acting. Okay, what will be the resultant force? That will be in this direction. That is the resultant force. According to the Newton's third law, the each and every force has some equal opposite force. So net force is in this direction. Okay, what is this coordinate? It is negative x and negative y. So pipe 1 related with the option D, 45 degrees to both negative x and negative y axis. Now come to the second pipe. In second pipe also the force is the water force is in this direction, and it is also the upward force also there. Okay, so the resultant will be like this. So the net resultant will be according to Newton's third law, it will be like this. Okay, that means water is pushing the pipe this wide, but pipe is giving reaction. So you have to take the reaction, not the resultant of water. Okay, here they are asking for the pipe force. Okay, how much pipe is going to feel the force. Okay, that you have to find. That is the resultant of the net force, net reaction. Okay, that is again the negative x-axis and negative y-axis. So the option for pipe 2 also option D. And for the pipe 3 case, the force is in this direction, horizontal force, and the vertical force is in downward direction. So the resultant will be like this, 45 to the x and y. So the net force will be, the net opposite force reaction will be like this. So it is negative x-axis and a positive y-axis. Negative x-axis and positive y-axis. Where is the option? Option B, negative x and positive y. Okay, option B is correct. For pipe 3, option B. For pipe 2, option D. For pipe 1 also option D matches. Okay, and next question. Streamlines, path lines and streak lines are virtually identical for, okay, these three are identical for the steady flow. We know that very well. And next question. And in a flow field, the streamlines and equipotential lines are always orthogonal. Okay, we know that. Check the options. Are parallel, wrong answer. Cut at any angle, wrong answer. Are orthogonal everywhere in the field, and cut orthogonal except at the stagnation points. Okay, we have a dilemma between the 2 points. Okay, what to choose? We know they are definitely orthogonal, equipotential lines and streamlines, but in the options C and D both are having orthogonal terms. Are orthogonal and cut orthogonal everywhere in the fluid and except at the stagnation point. So what is the stagnation point? Where the fluid will not flow. That means the point where the velocity is 0. At velocity is 0, the streamline is not defined. So if there is no streamline, how it will cut the equipotential line? Okay, the statement is exactly right. So except at the stagnation points, they are cut orthogonal. Okay, so this is the most accurate answer than this answer, than C. Okay, that's why we go for the option D. If this is not in the options, then we will choose option C. But it is there in the options except at the stagnation point. So then we have to choose option D. Okay, and next question. Circulation is defined as a line integral. So what is the circulation formula? Line integral u dx plus v dy plus w dz. So what is the circle means? It is a closed contour. So we have to integrate these in a closed contour, in a closed curve. Okay, the answer is closed contour. Okay, and the next question is, for a fluid element in a two-dimensional flow field, xy plane, it will undergo. Okay, so xy plane, it is x and it is y. Just take as reference. So a fluid element, what it can go? it can translate or it can have some shear. Okay, so the best option is translation and deformation. The shear means the deformation. And you can argue with me that is there any rotation? Rotation is a axis phenomena. So rotation, we always find the rotation about an axis, not about a plane. So he is given xy plane. So plane phenomena is a translation as well as deformation. So best option is C. Okay, and come down to next question. The velocity components u is given, v is given, the value of lambda for possible flow. So what is the condition for possible flow? It must satisfy the continuity equation, that is dou u by dou x plus dou v by dou y equals 0. Okay, I solved this question already in the lecture, so no need to solve it again, just an idea. And now the next question is the 2D flow with velocity. Velocity u is given, this is v is given, is asking whether it is a compressible, rotational, or incompressible or irrotational. It is very easy how to check the compressibility. Just apply continuity equation again, that is dou u by dou x plus dou v by dou y equals 0. If it satisfies, it is a incompressible fluid. Incompressible, that means if 0 equals 0, then it is incompressible. And check for the rotationality. How to check for the rotationality in 2D case? That is check only the omega z, that is 1 by 2 of z, means z after x dou by dou y. So y component here v, x component here dou u. So check this option. I already explained this question in the class itself, so no need to again solve this problem. So option D is correct. Okay, and next question. A fluid flow is represented by the velocity field. U is given ax, v is given ay, where a is a constant. The equation of streamline passing through point 1, 2. So what is the equation of streamline? That is dx by u equals dy by v. Okay, if you solve this equation with u equals ax and v equals ay, then you will get the option as, I think, x minus 2y equals 0. Yes or no? I already solved this problem in the class itself. Let me again solve this. So dx by x equals dy by y. So if I integrate, it is ln x equals ln y plus ln c, that is x equals yc. 1 equals 2c, so c equals 1 by 2. That means it is ln x equals ln y plus ln 1 by 2. Okay, I can write it as x equals 2y. That means x minus 2y equals 0. Yes, my guess is correct. Option A is correct. Okay, I already saw this question in the lecture. If you want, you just check there. Okay, and next problem, the velocity components. It is also solved problem in the lecture. The velocity components in x and y directions of a two-dimensional potential flow are uv. Okay, then dou u by dou x is equal to how much? So for a possible flow, what is the condition? It must be satisfy the continuity equation, that is dou u by dou x plus dou v by dou y equals must be 0. So from this, dou u by dou x equals minus dou v by dou y minus dou v by dou y. Option D is correct. Okay, and next question. These are very simple problems, but it is the toughest problem. A leaf is caught in a whirlpool. Okay, a leaf is there and it is caught in the whirlpool. That means it is observed in a whirlpool at a given instant. The leaf is at a distance of 120 meters. Okay, at a given time, at a given instant of time, the distance is 120 meters from the center. Okay, for example, it is the whirlpool. From the center, the distance is 120 meters at an instant. Okay, the leaf is here. Okay, the whirlpool can be described by the following velocity distribution. So he is giving the polar coordinate system, Vr and V theta. So Vr is given by minus 60 into 10 cube divided by 2 pi r, and V theta is given by 300 into 10 cube by 2 pi r. Okay, meter per second, absolutely, where r is in meters, is the distance from the center of the whirlpool. So r is the radial distance from the center at any radius, not the circumference. Okay, it is arbitrary radius. What will be the distance of the leaf from the center when it has moved through half a revolution? So it is moved through half a revolution. It is moved through half a revolution exactly up to this point. That is, half a revolution means theta is pi radians. Full revolution means circle. Circle means 2 pi. Half circle means pi radian. Okay. What he is asking? The distance. He is asking the distance of the leaf from the center. So what is the distance of the leaf from the center when theta is pi radians? Okay. So what is the basic idea to solve this problem? To approach this problem, what is the idea? He is telling that at pi radians, what is the distance? That means this theta is having relation with the radius. So that means if v theta is also having relation with the Vr, if you find a relation between v theta and Vr, you can solve the problem easily. So how we find that? The first way is to get the ratio between Vr and v theta. That is the only way that we can find a relation. So what is the ratio of Vr divided by v theta at a given radius? So we know one radius, that is 120 meter. Okay, or that is given in the problem, 120 meter distance. So I am applying that 120 meter here. So 2 pi r will get cancelled, 10 cube cancels. So minus 60 by 300. That means 6 5s are, that is minus 1 by 5. So Vr is given by minus 1 by 5 v theta. So from this I got one relation, but it is not at all useful for me to solve the problem further. Why? Because at pi radian, where I have to put the pi radians in this equation, there is no need, there is no place to put pi radian. Okay, that's why this is not at all useful right now. So we have to find another alternative, which is again in the form of Vr and v theta. Okay, in that case, that relation may be useful for us. So Vr can be written like dr by dt. Yes or no? Dr by dt, velocity, that is equal to minus 1 by 5. V theta can be written like V theta equals r omega. Oh, it is the angular velocity, tangent. Okay, if you draw a tangent to the angular velocity curve, that will be r theta. Okay, this velocity will be r omega. Okay, radial velocity means it is the radial velocity. Okay, in this direction radial velocity, and it is the tangential velocity that is given by r omega. So V theta is the tangential velocity at any angle theta. Okay, with that condition I am writing this r omega. Okay, what is omega? Omega is nothing but the angular velocity. Angular velocity means rate of angular deformation, d theta by dt. Okay, from the definition d theta by dt I can write. So dr divided by dt equals minus 1 by 5 r d theta by dt. So dt gets cancelled. So from this dr by r equals minus 1 by 5 d theta. As I got a relation between the theta and radius. Now I can find whatever I want. I know the limits of radius. The first limit is 120. Okay, I am going from 120 radius to some radius, I don't know that. So the limits of radius are 122 radius, 122 arbitrary radius r. So this is the location I want to find r. And what are the limits for theta? At here the theta is 0. Okay, I am taking this as theta 0, and I am starting from here and ending at pi radians. So theta limits are 0 to pi. Okay, so 0 to pi. So if I integrate, get at any radius, at any angle, I can get the radial distance of the leaf from the center. Okay, here the key to the problem is to getting idea. So how to approach the problem? First thing, they have given the theta. They are asking at a radius. At a radius, what is the radius? What is the radial distance from the center at a given theta? Okay, so you have to find the relation between the radius and theta. From the given problem, you have to understand the concept. So what we are going to find out? Okay, what is the given data? That's how you have to analyze the problem. After analysis, you have to come to know that you have to definitely find a relation between the theta and radius. So the only given data is Vr and V theta. So how you get the relation? Just take the ratio. If you take the ratio, you will get this thing. But this is not going to helpful for you. Why? Because here you can't put theta in this V theta, and you can't put radius, whatever you want. So next thing is writing Vr in terms of radius, writing V theta in terms of theta. So that is the next thing you have to do. So what is the Vr? It is the radial velocity. What you can replace with Vr? Dr by dt. Okay, that is the idea you have to know. This is the basic thing. And V theta you have to replace with the r omega. If you don't know how to write this step, then you will stuck at the problem, and you will commit a mistake like V theta means d theta by dt. So that is not d theta by dt. D theta by dt is the angular velocity. Okay, angular velocity is different than the this V theta velocity. Okay, here V theta is the tangential velocity, whereas Vr is the radial velocity. Okay, you have to know these formulas very well. Vr is the radial velocity, V theta is the tangential velocity. For tangential velocity, you have to represent with r omega. For radial velocity, it is dr by dt. Okay, dt with omega means again I can write d theta by dt. So dt gets cancelled. You will get the relation in terms of radius and theta only. So that is a required achievement, the first achievement. After that, just integrate to within the limits. You will get whatever you want. Okay, but how you get this idea? If you solve more number of problems, then ideas will come. If you just think I know the concept, I can solve any problem, then that is a blunder mistake. Whenever you solve more number of problems, then only ideas will come. Otherwise, they won't, and you will definitely stuck at a exam. You can't help yourself. If you solve more number of problems, that is the only way that you can achieve a good rank. Okay. Now come to the problem. It is integration, just integration. What is 1 by r? That is logarithm of r. So ln r from limits 120 to r, that is equal to minus 1 by 5 for d theta. It is theta in the limits 0 to 5. Okay, for what is the logarithm of if upper limit minus lower limit? So ln r minus ln 120 equals minus 1 by 5 pi. Okay, for 0 it is a cancel, no need to write it. So minus 1 by 5 pi. So ln a minus ln b means ln of a by b. Ln of r by 120 equals minus 1 by 5 pi. So take both sides exponential, then r by 120 equals e power minus pi by 5. Okay, minus pi by 5. That is r equals 120 multiplied by e power minus pi by 5, and that is 64 meter. Okay, and that is our answer, 64 meter. It is somewhat complicated, but if you find a relation, then it is very easy problem. Okay, integration part everyone will do, but this idea only some people will get. Okay, so solve more number of problems, then only you'll get ideas. And next question, come down to next question. What is the next question? A two-dimensional flow field has velocities along x and y directions given by u is given, v is given, where t is time. Okay, what is the use of time? The equation of streamline is, okay, he's asking the equation of streamline. So what is the equation of streamline? We know that dx by u equals dy by v. Okay, just put whatever u, whatever v. So from this, dx by x square t equals dy by minus 2xyt. Okay, from this I can write tt will get cancelled, and for x square it will cancel by one time. So that is dx by x equals minus dy by 2y. Okay, so if you integrate this, you will get ln x equals minus 1 by 2 ln y plus ln c. Yes or no? So that is equal to ln x equals ln y whole power minus 1 by 2 plus ln c. So this thing can be written here also, ln a plus ln b, that means ln of ab. So ln x equals ln of 1 by root y multiplied by c, ln of ab. So ln, so x equals c by root y, that is nothing but x root y equals constant. So it is the equation of streamline. Check the options. X root y equals constant. Oh my god, there is an option which matches with x root y. X root y is constant, so square on both sides, x square y equals constant. Yes, it is there. Now where is the option? Option x square y is constant, option A. Okay, and come down to the next question. In a two-dimensional velocity field with velocities u and v along the x direction, y direction respectively, the convective acceleration along the x direction. So he's asking the convective acceleration in x direction. Just a formula. He's asking just a formula. What is the formula? U dou u by dou x plus v dou u by dou y. U v w, u by x, u by y, u by z. Okay, he's asking just a two-dimensional. So it is the only formula. There is no term of dou u by dou t. Why? Because he is given that it is a convective acceleration only, not a local or temporal. Okay, so check the options. U du by dx plus v du by dy. Du has to be there, uv has to be there. Du here, uv here. Okay, it is correct. Uv u w. Okay, that is the sequence of remembering the problem. The formula. And now come to the next question. Oh, it somewhat seems complicated, but it is very easy. In a steady flow through nozzle is a one-dimensional case. We know that the flow velocity on the nozzle axis is given by, so velocity profile is given velocity profile is given as u naught of 1 plus 3x by L. Okay, I bar also there, where x is the distance along the x-axis, along the axis of the nozzle. Okay, let me draw the nozzle diagram. So it is the x distance from the nozzle. Okay, and from its inlet plane, and L is the length of the nozzle. L is the length of the nozzle. Okay, and the time required for a fluid particle on the axis to travel from the inlet to the exit of the nozzle. So from the inlet to the exit, what is the time required? He is asking a time required. Okay, what we know, the basic of velocity. So velocity is nothing but the rate of change of displacement, that is dx by dt. So with this idea we are going to proceed next. Okay, so from this I can write what is the way the given velocity function, u naught of 1 plus 3x by L. Okay, so just take that. So u naught of 1 plus 3x by L equals dx by dt. Am I correct? It is just a basic velocity formula, dx by dt, rate of change of distance. Okay, from that I can separate the variables and I can integrate. So that is nothing but it is u naught of 1 plus 3x by L dt equals dx. Okay, sorry, x term is here, so take this term this side, and that will become u naught dt equals dx divided by 1 plus 3x by L. Yes or no? So just integrate, then you will get the time. Okay, so u naught is a constant, so u naught into time equals integral 1 by x means ln of x, so logarithm of 1 plus 3x by L. And for the internal term, what is the differentiation? You have to divide. Okay, that means it is, for 1 it is 0 plus 3x by L means for x it is 1, so 3 by L, so 0 plus 3 by L. So what are the limits? Limits are from at 0 and final length L. So the limits are 0 to L, and the time is 0 seconds to time. So if you apply the upper limit lower limit, it will again time only. And if you apply the upper limit and lower limit will be 0, so no need to apply, and the upper limit is L, so just apply the upper limit. So u naught t equals L by 3 means 3 by L means it is L by 3, so L by 3 ln of 1 plus 3L by L. 3L by L means 3 only. Okay, so t equals L by 3 ln 4. It is the once again u naught is there, just so put u naught here. So L by 3 u naught ln 4, L by 3 u naught ln 4, L by 3 u naught. Option B is correct. Okay, very easy. The basic formula is how u equals dx by dt. But why I am writing this v here? Why this function I am writing here? Why? Because for one dimensional flow, what is the velocity? Velocity field, that is ui bar only. Okay, for one dimensional flow. For two dimensional flow it will be vj bar. For three dimensional it will be wk bar. But it is a one dimensional flow. The given thing is one dimensional, I bar only. So the velocity will be u only. So I can replace here. Okay, u term. So whatever the u term is here, I can replace here. Okay, just you replace that and separate variables and integrate between the limits. You will get whatever you want. Okay, that's it. The basic idea is the velocity equals dx by dt. If you know that idea, then the problem is simple. And next, come to the next question. What is that question? Oh, for the continuity equation given by divergence v bar equals 0 to be valid, where v is the velocity vector, which one of the following is necessary condition? So it is divergence v bar is 0 for what type of flow? It is for incompressible flow. Yes or no? Okay, for here there is no density term is there. It is a continuity equation. Okay, that is dou u by dou x plus dou v by dou y plus dou w by dou z equals 0. Okay, del dot v means it is the representation. It is for the incompressible flow. Okay, and next question. Okay, 2008 question, the most complicated paper, the GATE paper in the history of GATE exam. Okay, in 2008, it is said by the IISc Bangalore. It is the toughest paper up to now. Even the topper marks are about 78 to 79 marks only. But now it is 98, 97. Okay, it is the toughest GATE paper in the history of GATE exam. Okay, 2008, said by IISc Bangalore. Okay, between moving, what is the question? Is covered. This is a linked data question. The gap between a moving circular plate and a stationary surface, what's happened to the problem? Stationary surface is being continuously reduced. Okay, the gap is continuously reducing. Okay, as the circular plate comes down at uniform velocity, so it is a circular plate, it is coming down with velocity v, constant velocity v. Okay, towards the stationary bottom surface. Okay, it is coming downward as shown in the figure. In the process, the fluid contained between the, okay, some fluid is there between the plate and this stationary surface, and during this process the fluid contained between the two plates flows out. Okay, it is flowing outward, radially outward. The fluid is assumed to be incompressible, so the density is constant. It is an incompressible fluid and inviscid, so viscosity also negligible. What he is asking, the radial velocity Vr, okay, the radial velocity Vr at any radius r when the gap width is h. So the gap width is h. What is the radial velocity at any radius r? It is very easy if you know the idea. So whichever circular plate is coming downwards and pushing the, it is incompressible. So the fluid here, the contained fluid here will not stay longer here. So it will spill out. Okay. So whatever volume is decreasing in downward direction, that much volume will go up, will go radially outwards. Okay, that is a constraint here. So the discharge which is coming down, that is spilling out radially. So with that condition I can write a relation. Okay, so whatever the discharge coming downwards, that is the area of the circular plate and velocity. What is the area of circular plate? Pi r square. So sorry, small, not smaller, it is capital R. Why? Because the radius is capital R given. So it is pi capital R square multiplied by the velocity v. Okay, it is the discharge coming downwards, and that much fluid is going outward. Because of incompressibility, the fluid is not compressing. So whatever is coming downward, that must be goes spill outward radially. That is the only way it can go. Okay, what is the radial outward area? So the area is circumferential area. So that is like a this thing. Okay. Okay, this is the surface area. In this surface area, the fluid is going out. So what is the surface area? It is the circle area, circle perimeter 2 pi r multiplied by the h. Okay, that will give you the circumferential surface area. So through that circumferential surface area, it is going outward. The fluid is going outward with radius of Vr, the radial velocity. So what is the area? 2 pi r, the circumference, circle circumference, and the height will give you the circumferential area. 2 pi rh, and with the velocity of Vr. So Vr, so it is the basic idea. So from this he is asking just Vr. So Vr is given by, here R can be written like capital R. Why? Because the circle capital radius is we have taken. Okay, that's why it can be replaced with capital R. So capital R will get cancelled for one time. Pi. So what is the relation you will get? Vr equals V capital R divided by 2h. Okay, it is the relation. Check the options. Option A is correct. He is asking at arbitrary radius. So that means if you take a plate of this much radius only, then you will choose pi r square v. Okay, pi r square v. Then here also you take 2 pi rh v Vr. So in that condition, the small r will come here. So in place of capital R, you put smaller at any arbitrary radius. Okay. And the next question is the radial component of the fluid acceleration at r. So he's asking the fluid acceleration at r, the radial component of fluid acceleration, that is ar. What is the formula to find ar? Vr dvr by dr plus dv by dt. Okay, the radial is asking the radial component of fluid acceleration. It is very similar to the x component, y component. For x component, what we write? U du by dx plus v du by dy plus w du by dz plus du by dt. So similarly, I am writing here Vr dvr by dr plus dvr by dt. Okay. But in this condition, v is not there, w is not there, only radial component is there. So I am just taking radial component Vr dvr by dr plus dvr by dt. Okay, I know Vr in terms of V, in terms of capital V, but because here the options are in the capital V, okay, that's why I have to put Vr, replace Vr in terms of capital V. So it is a relation we obtained. So this question has to be solved using the first question answer. If you don't know the first question answer, then you will also lose 2 marks for this down question also. Okay, so this you total 4 marks are interrelated. Okay, so just substitute the values. So AR equals VR is VR by 2H, capital VR by 2H d by door of VR. What is VR? VR divided by 2H plus plus dvr by dt, the time component, unsteady local acceleration component, that is dou vr by dou t of vr is vr divided by 2h. Here the confusion comes because two variables are there, radius and height. So with respect to, if you are doing the derivation with respect to radius, what you have to take the variable and what you have to take the constant. It is very clear with respect to radius, it is a radius variable and h is constant. Okay, the first confusion over. So that is vr by 2h, for r it is 1, so that means v by 2h, plus here the confusion comes. If time changes, what is changing? Radius is changing or height is changing? Just observe the figure, what is changing. So we have to find the variable here. So if time passes, if time t equals 0 second, the plate is here. After time equals 2 seconds, the what is the plate position? It may be here. That means the height is decreasing. Initially the height is this much, but later 2 seconds the height is this much only. So the height is changing, but radius is not changing. Radius is constant. The plate radius is constant thing. It is not changing. So the variable is h here. Okay. So that is the key point here. Here with respect to t, if you do derivation with respect to t, the variable is h, not radius. Radius is a constant thing. So take vr by 2 outside of the derivation and derive only and differentiate only 1 by h. The differentiation for h is minus 1 by h square. So the differentiation for 1 by h is minus 1 by h square. So what is the vr divided by 2 multiplied by minus 1 by h square multiplied by dh by dt. Here I don't know the function of h in terms of t, so that's why I can write dh by dt here. Like what is the differentiation of 1 plus x? Ln of 1 plus x, it is 1 by 1 plus x multiplied by d by dx of 1 plus x. Okay, that will again come 1 by 1 plus x of 0 plus, for x it is 1, that will come 1 by 1 plus x. Okay, with that rule I am writing. So here I don't know the h as a function. Here I know the function is 1 plus x, but I don't know h in terms of t, so I can write dh by dt like this. D of function by dx, like this I can write dh by dt, the basic idea. Okay, from this it is v square r by 4h square plus vr by 2h square into minus dh by dt. There is a meaning I am writing that minus dh by dt. Why? Because here what is the velocity given? Constant velocity. Let me show you the figure. Here the velocity is v in downward direction. What is the velocity? The meaning of velocity, that is again distance by time, rate of change of displacement by time. So displacement is h here with respect to time. Here the distance is decreasing, so I have to put negative sign. So minus dh by dt is nothing but the velocity v. Okay, here velocity v is nothing but minus dh by dt. Do you agree with that? Velocity is defined as rate of change of displacement. Here the displacement is delta h, so coming downwards. Okay, rate of change of h with respect to time. Okay, so here the h is decreasing, so you have to put negative sign. So this minus dh by dt can be replaced with the velocity, given velocity v. So I am just replacing that condition. Okay, so that is equal to v square r by 4h square plus vr by 2h square multiplied by minus dh by dt, means it is velocity. That is equal to v square r by 4h square plus v square r by 2h square. Yes or no? LCM is 4h square. LCM is 4h square. 4h square. So it is 2v square r plus 1 v square r, that is 3v square r by 4h square. It is our answer. Check the options. What is the radial velocity given? 3v square r by 4h square. Option A is correct. He is asking at radius equals r equals capital R. So just replace small r with capital R. Replace small r with capital R. 3v square capital R by 4h square. Still the answer is same. So option A is correct. Okay. Here the basic idea is equating the volume constraint. Okay, the rate of flow constraint. That is, whatever volume is coming downward is going radially outward. The radial outward area is 2 pi rh, the circumferential area of a cylinder, imaginary cylinder. Here the downward area is the plate area multiplied by the height. That is the cylinder area. Okay, cylinder area, and you will get a relation between VR and capital V. So with that relation you have to solve the next problem. Otherwise the problem is not solvable. Without the first question answer you can't solve the second question. Okay, these two are interrelated. That's why it is a 2008 IAS Bangalore question. Okay, there must be some tricks. You are asked to evaluate assorted fluid flows for their suitability in a given laboratory application. What is this bullshit? The following three flow choices expressed in terms of two-dimensional velocities in the xy plane are made available. So he is given UV for three conditions. Okay, the three choices. Which flow should be recommended when the application requires? So it is the main thing. Application requires the flow to be incompressible. The first condition is incompressible and the second condition is irrotational. How we check the incompressibility? Just apply the continuity equation. Dou u by dou x plus dou v by dou y equals 0. So if it comes 0 equals 0, that is okay. Okay, that fluid that flow fluid you can select that. Okay, and the irrotationality checking. So how can you check irrotationality for a two-dimensional flow? Just check omega z, that is 1 by 2 dou by dou x minus dou by x y component here, x component here. Okay, here also check for the angular velocity with respect to z axis. Then if it comes 0, the fluid is irrotational. Okay, if it comes some value, the fluid is rotational. So he is asking to choose the irrotational fluid. So you have to check for the P, Q, R. The three conditions you have to evaluate using these three relations. Okay, check for the P. Let me write those here. P is 2y minus 3x. P is 2y minus 3x. For P, 3. What is the velocity profile? 2y 3x. U is 2y, V is minus 3x. Okay, V is minus 3x from the given. So just substitute in the continuity equation. For dou u by dou x with respect to y is a constant, so it must be 0, plus with respect to y this thing is 0. So 0 equals 0. P is passed in the test of continuity equation. So it is an incompressible fluid. And check for the rotationality also. So 1 by 2 of dou v by dou x with respect to x, it is minus 3, and minus dou u by dou y with respect to y, it is minus 2. So that will be minus 6 by 2. It is having some value, so it has not passed the test. So delete this answer. Okay, so fluid P cannot be chosen. Next, what is the fluid velocity profile? That is Q. 3xy 0. So u is 3xy, v is 0 for Q fluid. Just apply the continuity equation. Dou u by dou x, that is 3y, plus for v it is 0 equals 0. It is satisfying? Not it is satisfying. So no need to check for the rotationality. This is also not satisfied condition. And next the given fluid is u equals minus 2x, v equals 2y, minus 2x, 2y, minus 2x for r, minus 2x, 2y, u, v are given. So just apply the continuity equation. Minus dou u by minus dou of 2x by dou x, that is for minus 2x it is minus 2, plus for dou v by dou y it is 2. So it equals 0 equals 0. First condition is okay. Next, check for the second condition. Let me have some space here. Second condition is rotationality. 1 by 2 of dou v by dou x, so with respect to x it is 0, minus dou u by dou y, there is no y term, so it is 0 again, so it will be 0. So 0 equals 0. Condition is satisfied. So it is a irrotational as well as incompressible. So R passed both the tests. So select the fluid which is having the velocity field of R. Option D is correct. Very simple. And next question, the velocity vector of a flow field is given as, velocity vector is given u v. Whatever in front of I is u, whatever in front of j is v. The vorticity vector at, he is asking the vorticity. What is the vorticity? Vorticity symbol is this symbol. Okay, it is given by uh, del cross v bar. Okay, you know that very well. It is a curl. So how to find the curl? I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, u v w. Yes or no? So here u v are given. U v is 2xy, v is minus x square z. U v is given as 2xy and v is given as minus x square z. Okay, just substitute the values here. That implies modulus of I j k dou by dou x, dou by dou y, dou by dou z, and u is 2xy, v is minus x square z, and it is 0, no component. So you have to find the curl. So I into this multiplied by this, so it is 0 ad minus bc. So plus x square, dou of x square z means x square only, x square minus j bar of, this will cancel and you have to find this 0 minus ad minus bc. For this it is 0 again, and plus k bar of this thing cancels, and the remaining is ad minus bc. It is dou of x square z, that is minus 2xz, minus 2xz minus 2xz minus bc. Bc means dou xy, for 2, for 2xy it is 2y, sorry y, okay, it is 2x only, 2x. Okay, it is the condition. That is x square I bar, minus, sorry, plus k bar of 2xz minus 2x, minus 2xz minus 2x. Okay, so from this what is the condition given? Is given a point. What is the point? The point is 1 1 1 1 1 1. Just apply the point here, just substitute the point here, 1 1 1. So 1 I bar minus k bar, if you take common, that is 2 of 1 1 plus 2 of 1, that will be I bar minus 2 plus 2 4 k bar. Okay, check the options. I bar minus 4 k bar, I bar minus 4 k bar. Option D is correct, I think. I bar minus 4 k bar. Very simple question. Just find the curl. That's it. The next question is, a streamline and an equipotential line in a flow field. We know the streamline and equipotential lines are orthogonal to each other, so the perpendicular to each other. Option B is correct. Okay, very easy. And the next question, for an incompressible flow field V, which of the following conditions must be satisfied? Incompressible means it must satisfy the continuity equation. What is the continuity equation? Del dot V bar equals 0. The divergence V bar is 0. So option A is correct. No need to check for the options, remaining options. Very easy. A flow field which has only convective acceleration. Oh, a flow field which has only convective. That means it has no local acceleration. That means the velocities are not changing with respect to time. So that is a steady flow. Definitely, if convective acceleration is there, that means some velocity or velocity profile is there with respect to the space coordinates. Then it must be a non-uniform flow. Yes or no? So it is steady and non-uniform. I clearly explained these things in approximately half an hour. In the first introduction lecture, I explained the steady, unsteady, uniform, non-uniform, rotational, irrotational, laminar, turbulent, all the flows. And in the acceleration formula discussion also, I explained these things very clearly. When the steady flow acceleration will become 0, and when the local acceleration will become 0, when the convective acceleration will become 0. Okay, if you just refer the table, you can answer any question based on those decision parameters of steady and unsteady flows. Okay, and the next question is, consider the following statements regarding the streamlines. Okay, the streamline statements, we know very well about the streamlines. It is a continuous line such that the tangent at any point on it shows the velocity vector at that point. Absolutely correct. Okay, It is a continuous line, absolutely. If you draw a tangent at any point, that will give you the velocity vector. It is correct. There is no flow across the streamlines. Yes, there is no flow across the streamline. The flow is only along the streamline. The flow is only along the streamline, not across the streamline. This is also discussed thing. It is correct. And the equation of streamline is this thing. Very well. And in an unsteady flow, the path of a particle is a streamline. Wrong. In a steady flow, the path of line is a streamline. For steady flow only, the path line, streamline, streak line will be uniform. It will be coincide with each other. Otherwise, they will never. So option 4 is wrong. So what he is asking, what is intention? He just asked to choose the best combination. So 1, 2, 3 are correct. Option D is correct. Okay. See, these questions are very easy. If you know the concept, you can answer these questions within 1 minute. Okay. Very simple. Until now, there is no hard question except that 2008 problem and that leaf problem. Okay. Those two are some complicated ones. Otherwise, each and every problem is very simple. And the next question is, consider a velocity field V equals, the velocity field is given, U equals ky, V equals 0 because there is no J component, I component and K component. Okay, don't go in a hurry way. If you go in a hurry way, you will come to a mistake that you take this Kx as V. Okay, because please observe carefully, it is not a two-dimensional flow. Even though it is a two-dimensional, why? Because only I bar and K bar only there, but you will assume that it is a I bar and J bar. You take it as a V, but here V is a 0 because there is no component of J bar. Okay, and W is Kx. What he is asking, where K is a constant, the vorticity around Z is how much? Okay, it is given by 2 times of angular velocity around Z. Okay, that means 2 times of 1 by 2 of dou by dou x minus dou by dou y component here, x component here. Okay, that means 2 into 2 cancels, no need to write 2 again. So dou v by dou x, what is the dou v by dou x? It is 0 minus dou u by dou y, it is k. So the answer is minus k. Option A is correct. Okay, don't go in a hurry way. If you go in a hurry way, you'll come to a mistake that you take v as kx and you put here kx, then option will be 0. The 0 is not in the options, then you will definitely got in a tension. Okay, so don't go in a hurry way. Just read the question carefully, whether he is giving the k bar or j bar. Okay, that is my suggestion. And next question, I think I solved this question in the class, so no need to explain it again. Option B is correct. The slope of potential line. So what is the slope of streamline? Slope of streamline, m1 multiplied by m2 equals minus 1. If potential line slope is minus u by v multiplied by m2 equals minus 1, that is m2 equals v by u. Okay, it is the slope of streamline. Just apply this product of slope equals minus 1, then you will get the slope of another line. Okay, and next question is match the following question. Del cross v, cross product means curl means it is of representation of vorticity. Here what is the vorticity? Incompressible, no. Study, no. Irrotational, yes, it is some relation with irrotational because vorticity is given by 2 times of angular velocity. Okay, that's why we can write that. And divergence is relation with the incompressibility flow. Incompressible, so it is relation with this q1 p3 q1. Option C and option D are both are matching. Okay, dv by dt is 0. Okay, that means that is change of velocity with respect to time is 0. That gives you the 0 acceleration of a fluid particle. Okay, and dou v bar by dou t equals 0. That is the steady flow definition. The change of property with respect to time is 0. That is the definition of steady flow. So what is the condition? P3 Q1 R4. P3 Q1 R4. So option C is correct. And S2, definitely S2. Okay, very easy. And again come to the next question. I solved this question already in the class, so I need to explain it again. Just I will give you some idea. A1 plus B2 plus C3 equals 0. Okay, that is the condition. So A1 is given as 2 plus B1 B2 have to find that plus C3 is minus 4 equals 0. So B2 equals plus 2. That's it. And next problem. Okay, I have given this important point. The volumetric flow rate per unit depth. between the two streamlines for a given stream function xi1 and xi2. Okay, what is the formula? Xi1 minus xi2, difference of xi1 minus xi2. You have to put a modulus sign to get the discharge in a positive way. So the option D is correct. I have explained this thing in the class also. No need to explain again. And next question is, for a certain two-dimensional incompressible flow, velocity field is given u, v. The streamlines for this flow are given by the family of curves. So find the streamline equation. What is the streamline equation? That is dx by u equals dy by v, because it is a two-dimensional. Okay, no need to take the dw by or double dz by w component, only two components uv. So from this, dx by 2xy equals dy by minus y square. Okay, from this y gets cancelled for one time. That will be dx by 2x equals minus dy by y. So integrate, just integrate. Then you will get 1 by 2 of ln x equals minus ln y plus ln c. Okay, so from this it is ln root x equals ln of a minus ln b, that is ln of a by b, ln of c by y. Okay, so ln cancel, so root x multiplied by y equals constant. So x square y x y square equals constant, squaring on both sides. So constant square again constant, so no need to take c square. So x square xy square is constant. Check the options. Xy square is a constant. Option B is correct. Okay, very easy question. And the next question is something very complicated seems. A two-dimensional flow, the velocity field is given where uv is given as x by x square plus y square and v is given as y by x square plus y square. Very big functions where I bar j bar. Okay, we know that very well. What he is asking, identify the correct statements. The flow is incompressible. What is the condition for incompressible flow? It must satisfy the continuity equation. Dou u by dou x plus dou v by dou y has to be 0. So check first this condition. If it is satisfied, then we'll go further. Okay. So dou u by dou x of u, x by x square plus y square plus dou by dou y of v, y by x square plus y square. Okay, equals 0. So it is in the form of u by v. So what is the formula for u by v? U by v, d by dx of u by v. So d by d of u by v. What is the formula? It is very simple. Low d high minus high d low by low square. Low means low, v d high means du minus high d low. High means u d low, d of lower term divided by lower square, v square. Okay, it is a formula. So that means x square plus y square, differentiation of the numerator, that is 1, minus x multiplied by differentiation of denominator dv, that is 2x plus 0 divided by x square plus y square whole square plus here again u by v formula, that is vdu x square plus y square multiplied by 1 minus y multiplied by 2y. Okay, 2y divided by x square plus y square whole square, that is equal to 0. Just take the LCM. LCM is x square plus y square whole square and x square plus y square minus 2x square plus x square plus y square minus 2y square. So plus y square minus 2y square plus x square minus 2x square, that is 0. So 0 equals 0 satisfied. So the flow is incompressible. The first statement is correct. Check the options for the correct answer. Oh my god, option 1 is having B in B and in C. So we have to choose the option B or C only. So we have to check only statement 3 and statement 2. No need to check again the statement 4. Okay, what is the statement 2? The flow is unsteady. Okay, the given statement is the flow is unsteady. Is it unsteady? If there is a component of time, then the flow is said to be unsteady. Here there is no component of time. That means the flow is steady. So statement 2 is definitely wrong statement, because there is no component of time. If there is some component of time is there, then the flow is varying with the time. Okay, the velocities are varying with the time at a given cross section. Here the time component is not present, so the flow is definitely steady flow. Why? Because there is no time component in the given equation, so the flow must be steady. So two option can be eliminated. So the only option with including one is option 1 and 3. Okay, option B is correct. If you try to find acceleration y in y direction, that will be very difficult thing. You have to find u du by, sorry, in y direction means u dv by dx plus v dv by dy. So this much big thing you have to multiply. U means again x by x square plus y square, v means y by x square plus y square, and multiply with the differentiation. That is a very big equation. So don't go for that. Just it is a 2 mark question. GATE doesn't test your differentiation skills. Okay, they only just test your basic. So the basic is the flow is steady flow. How can you say that? Here there is no time component. If there is no time component, then definitely the flow is steady flow. With that note, I can directly eliminate this 2. Okay, so that's why our option is 1 and 3. 1 and 3 are definitely correct. The acceleration in y component must be like this only. This is the y component. No need to solve the problem. Okay, if you want, solve the problem. I don't worry. And next question, come down. Consider a two-dimensional. This question I think I solved in the lecture, so no need to solve it. The answer is a1 plus b2 equals 0. So option B. Okay, and come down to the next question. That is, for a steady flow, the velocity field is given like this, and the magnitude of acceleration. Okay, I think I have already solved this question also. The answer is 2 root 5. Option C. And that's all questions are over except 2018 question. Okay, the 2018 questions are for exercise for you. Okay, you check those questions in the internet and solve those questions by yourself. Okay, that is for you. Thanks for watching.